Yes, hello everybody who um, still there. So are you ready for little philosophy? Because this is what's going to happen. Just a little bit of my credentials. I've been doing software for like 14 years. Up to now, last 2.5, it's been at Wolt. So I started as a fintech, and then I moved to Wolt market, where I'm now. And I'm really interested in languages and understanding. And I think that's part of why I'm a software engineer and part of why we're having this talk today. So everybody says that code should be readable. The code that we write, it should be readable. It must be understandable by other members of the team or even wider community. But few of the people can actually tell me how to write the code so it would be readable. I ask that question often when I do hiring interviews, like how do you make code beautiful, or how do you make code readable? And people usually answer along the lines like, oh, this code should have tests, it should pass static analysis, naming should be right, like this is also popular, but what is the right naming? Like why static analysis is the way it is? Like, are we just believing some experts, or do we actually understand why are we using those tools to analyze our code? Or, you know, like people like, what is understandable code? Understandable code is the code that I can understand. Well, thank you, but I have my English dictionary. I think I it's enough. But yeah, the specifics, like why are we doing this way and not other way? And when you read books like Clean Code or some other books that I've encountered, like Code Smells articles, they say like, okay, this is bad, don't do that, do instead like other thing, because like it's harder to support. Like when you actually do the software and like do the practices, or like don't do the practices and then meet the consequences, you kind of understand that this is true. But why? And what I'm going to talk about, like, we are actually not writing our code for computers, because computers don't speak our languages. They don't speak Java, they don't speak Kotlin, nor Python. They speak some other language, like JVM speaks bytecode, and computers in general, they speak their own machine code, which we do not speak. None of us, I think, maybe with the exception of Yarko, and I don't know, maybe some hardware enthusiasts are here on the call, but I definitely don't speak that. What we do instead, we are writing documentation for how we solve the problem. What was our logical process? So instead, we just documenting the process of logically solving the problem. And we do that in order to later improve, like fix the bugs, or like do more, add new functionality. So it's like blueprint, which is also a building. So, and as long as it's documentation, it's a text. And as long as it's text, we have a lot of studies that are actually dedicated to understanding how text work, how like understanding work, what is a good text, how to make texts better, and how it all works. And then we kind of mired in a huge philosophical bog, because this is the fundamental question of hermeneutics. How do you know that you know what you know, and how do you know it? And by nature of philosophical questions, it's unsolvable, but people do try to answer that anyway, and they answer it in part, or like every time they try, they kind of chip away a little piece of understanding. And as of the time, the understanding came to roughly this picture. I will talk about like where it went after that, but basically it was that. Like we have a symbol which denotes the concept, which kind of describes it, and it lives in our head. There is no actually concept of a cat walking. There are real cats which have nothing to do with what's living in our head. But then you get to be involved with sender of a symbol, and then somebody will receive your symbol, you receive your message, and then there would be a context, like other messages that were sent before or will be sent later. And this context also defines how the understanding would work. And this is a huge sort of subjectivity, because of course, if what you say means different things depending on who are you saying that to, that's kind of a huge piece of subjectivity right there. So how does that help? How does that excursus to philosophy helps us? Well, it says us, it tells us from where the most subjectivity comes from, and it comes from the reader. And just let's start with the simple things. We must have code reviews, because without code reviews there can be no readability, because subjectivity comes from the reader, and if your readers do not understand what you're trying to say, your message is useless and your code doesn't work. So it might be working for computer, but it doesn't work as a documentation. What else can we say? Like, if only one person can understand you, if you only submit your PRs to only one person, then probably it's not going to work either. So it would be a good idea to submit code to different people at once, or every time you submit a PR, submit it to a different person, because that's how you develop your style, which would be understandable to more people than one. And then, like, how also can we do that? How can we talk about style in the team? So our solution in our team was to create a repository of MD files and just plain describe it. Okay, we are using this, and we kind of doing that in that way, and this is like the good way, and it's a good practice. Well, but the thing is that people do not like to invent new things. Sometimes they do, but usually it's like what's in front of them. That's what they're trying to invent. They do not invent to the left and right, like they use the tools for the job that they already have. So if you give people already working way to solve problems, they will use it. So that's what we've done. So we have best practices in our repository, and everybody can PR them. Another thing that we are coming to when we are thinking about code as a text, we are looking at practices that, you know, writers practice, like how does Stephen King writes his novels. Actually, I listened to his book very attentively, and one of the big takeaway for me personally was write everything twice, once behind a closed door and once with an open doors. What this does, like, first time you write the code or the message or the article or whatever, just to get it done, like from point A to point B as soon as possible, like and if you imagine something, so get something wrong, it's not a big deal. You just go on until you reach point B, and then you go back and rewrite everything. But at that point, you're starting to ask for reviews, like when you kind of maybe halfway down or something. This is this is taking much longer time than it would have done if you just wrote it once, but it pays later when nobody can remember why they wrote this. And this is also why you should have code review. Like, we will talk about this about like in a couple of minutes, because yeah, another thing that writers do, they tell the story, right? The story should be gripping. The story should be kind of understandable. We should, I would dare say that we should empathize with our main character. So that kind of also can be seen in code sometimes, like when code is very passive and it kind of suffers things that are done to it instead of doing things himself. So it's kind of you can see that, and we will see some examples just in a few moments. So why it's important to tell the story is because we have a huge memory. You don't believe this maybe, but we do. But this memory has a very large time for writes. So we can put whatever in there. We can put basically trees. Psychologists, like cognitive specialists, call that schemas. So it's like a concept which might consist of other concept and be part of still another concepts. So like things that are interconnected. So that looks like a library of trees to me, or like a library of indices, or something like that. So a database, basically. Read is very quick, but write is unreliable and long. And then for like working thing, we have working memory, and it's really small, and it holds like whatever, but only a few things, like maybe 5 or 4. Like on average, it's 4. I think for like us intellectual workers, it's slightly higher, but still like maybe 5, 7. But every time you exceed the capacity of your short-term memory, you start to lose things, and it takes you a long time to understand. If you cannot hold the concept in your short-term memory, it doesn't become a schema at all. And what that tells us right away is like 4 of everything is enough. If you want your code to be understandable, then it's kind of keep it under 4 anything, 4 arguments, 4 I don't know, clauses, 4 conditions. Like this is the first example that I'm going to bring in, like why the second way is a bit better than the first way of writing code. It's because when we are trying to read the first way, we trying to understand the whole thing at once. Okay, so here we have function h of z, of result of function g, of y. Okay, this is the time that I crossed that barrier of 4 things, right? And I'm barely able to take in function f. And when I rewrite it in a fluent sort of way, then it becomes a pipeline. So I'm applying things like filters on your photograph or whatever, and it kind of easier to understand. And I see, okay, this is A, and I am applying function with 1 argument to it. And to the result of this, right, I am applying another function. So it kind of becomes gradual, and I can form the concept of what's going on. And it's much harder if I do it other way. Another thing that helps us is to have a simple overarching principles, like principles that hold true everywhere in the code. Why is it important? It's important because you are creating schemas. When you're creating schemas, you facilitating understanding right away. If you can use schemas consistently to understand your code, then it will become much easier to read. Why I insist that they should be simple? Well, simple schemas are easier to create in your long-term memory. Other things that we can take from cognitive load theory is that there is some effects which arise when people try to learn new information. And reading unfamiliar code is always learning. You're trying to learn what this is about. So there are multiple effects, but some of them more relevant than others. One of them is redundancy effect. Sorry, there is like the overexcited dog in my apartment. So there is redundancy effect, and then there is split attention effect. Redundancy effect is best illustrated like this. So if you look at the code, I'm sure that it takes quite a bit of time for you to understand it, unfortunately. And this is also the problem of the books on proper code. They usually present you not so bad example in the first place, and then they say, okay, now we are making it better. But what happens in real life, you have 3,000 lines of code, which is completely impossible to understand, and you're trying to do something about it. So instead, like simple examples do not work in this area, unfortunately. But look at this, like at first lines of both functions. They are kind of similar, right? In fact, they are identical. And the second lines they are not identical, but very, very similar. And the fact that we are repeating them takes away from our ability to understand what those functions are about and what they are doing. So if we were to contract them and put them in a simple function, which might be taking cell type as an argument, we can do better, and we will be creating more readable code by eliminating redundancy. And this brings me to another thing, like minimalism in general, like using less symbols. You're using less symbols, you need to read less symbols. Using less, I don't know, concepts, less everything. It's usually beneficial for obvious reasons. You don't have to create so much schemas. You don't have to read so much things into your short-term memory. So less is more almost always. And another example of this, like this is a huge function. Well, it's not huge, but it's kind of sizable. And what we are trying to do here, we can load the venue ID while some factory, and it might throw, and then we get the venue itself, and then we're trying to do stuff to it, and we can also throw, and there is also nested things inside that function. So all of this takes away from our ability to understand what's going on, because we have to keep track of so many things here. And moreover, like there is a split attention here as well, because there is throw here and return there and two other throws, and all of those are exits from the function, and we kind of trying to watch them all, trying to see, like if we put here like test input in our head, like 3, what's going to happen here, like will it go through that exit or other exit? So we're trying to catch this control point. But look at what we can do with a bit of functional approach here. I'm not saying that functional approach is like the only proper approach here, but it might be beneficial, and we'll talk about it in a bit. So what happens here is that we are telling a story. So we find in venue ID, we converting it to a venue which should be open, like our names are telling the story, like what are we trying to do here? Is this venue has space to store that amount of code? And if it is, then kind of let's try to store it. So this is like the whole thing, like the whole process, and it's linear, and everything linear is, well, obviously easier to understand if you don't have to hold 2 or more versions of reality in your head. It's much easier. Yeah, this is another example to the same end. Like in yeah, what was I saying above? Like this thing uses arrow KT. Underneath, we will look at the functions just in a bit, but it's not always necessary. Sometimes less is more. Sometimes you don't need arrow KT. Like here, there's either conditionally, which would return right if it's false, and will return left if it's true. Like if it's really null, then we will do something, and otherwise we will do something else. And then we will do some kind of merge, and we don't need any of this. Like if its internal venue ID is 0, sorry, it's null, then we just don't do the whole branch. We just returning like some default answer. And if it's not null, then we just, proceed with the stuff. And this brings me to another thing, like how can you do more and do more readable code and tell the story? If you create more schemas, then you can express more and more complex concepts, and you can kind of gradually rise that layer of abstraction, like scales of abstraction, to the level where you can just do stuff. Like think of your, like I think usually of my domain, like what I am doing. I am receiving an order. Can I write my function in a way that I'm just receiving an order? Like what would that entail just on the one little step behind? Okay, maybe I don't know, I open the iPad and I look at the screen and just click on the order that has come to me to accept it. So this might be beneficial if you gradually go down to the more and more detailed stuff, but keep also high level conceptions in your code, like this one. So that simplification that I showed previously in an example, of course, it's not like I put away all the checks. I couldn't have done, because I still need to do them. But what I can do with them, I can hide them temporarily until we actually need to know about them. What we need to do right now, we need to tell the reader that we are getting the venue ID, we are converting it to a venue, we are checking that venue is open. And how exactly do we do that? It might never interest our reader, because he's interested in other stuff, or maybe he's just, wants to look through, and it's not his princess is in another castle, so he just wants to go other way. And yeah, this brings me to the end of my talk. So we should be aware, in order to write a readable code of cognitive load, that our code puts on our readers, right? How do we do that? Well, we do that through minimalism, through using less symbols, less stuff, but at the same time, it's a dialectic process. We do that by creating new schemas, new layers of abstractions where it's really needed. We're trying to kind of plant the trees in our long-term memory. And yeah, that is basically it. I will be happy to answer any questions. And at the end of my talk, I want to say a huge thank you to everybody who has come there and stayed until the end of my talk. Thank you very much. Thank you for attention. Thank you for being there. I want to thank Isabella and Anna from our people team for organizing the whole event. Without them, it wouldn't have happened, and they did a huge work on this. Also, thank you, Hannah, for being an MC at this event, and thank you, Jarko and Dmitry, for being speakers there. I hope this is not the last Kotlin meetup in Wolt, and we will meet again. Thank you and good night.